question for exercise 3G, question 2f. And again, with these kind of questions, you should be trying to sketch the graph. So assuming that you've got the skills to sketch it at the moment, let's have a look. F says you've got 7 minus 2 times x, brackets 2x minus 3, and you want that to be greater than or equal to 0. So let's draw the graph. Now to draw the graph, we know that it's already factorized, so we can solve for the x-intercepts. And how do you solve for the x-intercepts? So let's say the equation is 7 minus 2x, y equals 7 minus 2x times 2x minus 3. To find the x-intercept, you let y equal to 0, and you get 7 minus 2x, bracket 2x minus 3. And we can use null factor law to then say 7 minus 2x needs to equal to 0, or you can also have 2x minus 3 could equal to 0, so it's either one of the two. Let's solve for them. Minus 7 on both sides, you get negative 2x equals negative 7. Divide both sides by negative 2, and you get 7 on 2 for one of the solutions. And then same thing over here, we add 3, because that's the opposite of minus 3, and then divide 2, because that's the opposite of times, and we get 3 on 2 is our second solution. So that means the x-intercepts are at either 1.5 or 3.5, okay? Or you can leave it as fractions, but 3 on 2 is somewhere over here, and then 7 on 2 is somewhere over here, right? What we can tell is what type of graph is this? Is this a frown type of shape, or is it a smiley type of shape, so inverted or upright? And we can see that if you actually expanded the brackets, there's a little bit of a trick here. It was negative 2x times with 2x, and there was a little hidden one. If you expanded it, it would have actually been negative 4x squared, and then whatever the rest doesn't matter. It's that negative 4 tells me that it's a frown. If it was positive, it would have been an upright shape. So if it's negative, it's inverted. So I know that the shape of the graph must look something like this. And if you weren't really sure, you can always try to check by finding the y-intercept. It will tell you. If the y-intercept is positive, then clearly it'd have to be an upright shape. And if it's negative, well, then it has to be inverted. So there's a couple of ways to do that. So if you wanted to find the y-intercept, what you could have done is you should have let x equal to 0, and in this case, y is equal to 7 minus 0, and then 2 times 0 again, so 0 minus 3. And what you find is you get 7 multiplied to negative 3, and that gives you negative 21. So that implies that the y-intercept is in the negative region, and so the only way to connect all three dots would have to be an inverted shape or a frown type of shape. Now that we've sketched it, okay, we've got the graph, now we can read the question. So the question wants you to find when is the graph, and it says here greater than or equal to 0. We know it equals 0 at these 2 points. At those exact 2 points, we've got 3 on 2, 0, so the y value is equal to 0. Here is 7 on 2, 0, and again, the y is equal to 0, so we've ticked off the part where it says equals 0, but we then need all the y values that are greater than 0. And you can see all these points on this curve, if I connect it back to the y-axis, they're all positive y's. They're all greater than 0. So the region that you're interested in is actually between 3 on 2 to 7 on 2. So that means my answer would have to be, well, x can be any number between 3 on 2 to 7 on 2, but you can also have it equal to 3 on 2, because when it's 3 on 2, the y value is equal to 0, and it can also equal to 7 on 2 because it's also equal to 0, because that's what we wanted. We said either equal or greater than 0. So the only way to get this top region, which is greater than and equal to, it has to be between 3 on 2 to 7 on 2, but equivalent as well. Okay?